Welcome to part 2. In this video, we're going to talk about graphing absolute value equations and parabolas, simplifying radicals and imaginary numbers, solving quadratics by factoring, taking the square root, and completing the square. So let's go. Beginning with question 9, they're asking us to graph this equation and to give the coordinates of the vertex. So if I write the general form, we'd say f of x equals your a value times the absolute value of x minus h plus k. And a quick reminder, your h and k represent the vertex. So looking at our equation, we can see that our h value is 3 and our k value is -1. This is the first point that you can graph on your coordinate plane. The second thing you want to look at is your a value, which is +2. If it is positive, that tells you that your graph should open upward, so it should look like this, with a slope of 2. And with slope, think of this as 2 over 1. So from that point we just plotted, we're going to go up 2, so 1, 2, and go to the right one, and also go to the left one. So these are also 2 other coordinates. So from there you can connect. You don't need any other points. And since we know the absolute values are V-shaped, we are able to create this graph. Now, if you don't feel comfortable with this method, you can always make a table of values as well. So let's say we wanted to choose 4. Let's just confirm that one coordinate is going to be 4, 1. So if I plug in 4 into my equation, you're going to copy your function as is. So y equals 2 times x, which we wanted to be 4, minus 3 minus 1. So if we further simplify, we get 4 minus 3 is 1, minus 1. We end up with 2 minus 1, which gives us +1. So we still end up with that coordinate 4, 1. Let's choose another point. Let's choose x equals 5. So y equals 2 times 5 minus 3, minus 1. When we simplify, this part ends up being 2. Minus 1. 2 times 2 is 4, minus 1 equals 3. So another coordinate will be at 5, 3, which we did predict, by the way. It's right here. So that's another way to graph functions like these. Just make a table of values and connect your points, and you'll make your graph. For question 10, we are expected to graph and find the coordinates of the vertex. This function is written in standard form, which, quick reminder, looks like this. And in a quadratic equation, you can find the vertex by solving for x using this formula, -b over 2a. Our b value is always in front of your x, which is -4, so we're going to put -4 in parentheses, so we can distribute the negative afterwards, all over 2 times your a value, which is in front of your x squared, and that's +2. We're going to further simplify. We have 4 as the numerator. 2 times 2 is 4. So the x value of your vertex will be 1. Now the second part is to plug in this 1 into the original function. Wherever there's an x, you're going to plug in a 1. And simplify. 1 squared is 1, and 1 times 2 is 2. -4 times 1 is -4, plus 4. Notice how the 4's cancel out, leaving you with just 2. So the coordinate of your vertex will be at 1, 2. So you can graph this at 1, 2. With parabolas, we know that they have a U shape. Our a value is +2, which tells us it's going to open up like this somehow. The next thing you can do is make a table of values. So let's do that on the side. I'm going to choose 0. That's the easiest thing. Plugging in 0 to our function, we get 2 times 0 squared, which is just 0, minus 4 times 0. Again, that's 0. So really, we're just left with the constant. Y equals +4. So we end up with the coordinate 0, 4. That's also something you can graph. Since parabolas are symmetrical, we can also place another dot right here. let's just find one more coordinate to make this graph more accurate. So let's say x is 3. So plugging that into your equation, we get 4 times 3 plus 4. We simplify, 3 squared is 9, 9 times 2 is 18, minus 4 times 3 is 12, plus 4. 18 minus 12 is 6, plus 4 is 10, which is perfect because our graph can go up to 10. So this coordinate is at 3, 10, which is right here. And again, since parabolas are symmetrical, and here is our axis of symmetry, let's add one more dot to the left 2 spaces. And then we can connect the dots that we created. Try to make it look like a U shape since that's how a parabola looks like. And that's how we can graph question 10. Question 11 is already written in vertex form. We know it's a parabola because it has a power of 2. So the vertex form, your h value is the opposite sign of this 4. So although it says plus 4 in the parentheses, our h value is actually negative 4. And our k value is the number outside, which we take as is, negative 4. Putting these together, our vertex is at negative 4, negative 4. And we can graph that right now. It's this point right here. Our a value is positive 2. So from the point we just graphed, we're going to go up 2 to the right one, and then up 2 to the left one, since it's symmetrical. Let's try to find one more point to make this graph more accurate. So let's make a table of values on the side. Let's choose x to equal negative 2. Let's see what we get. So we're going to plug that into our equation. Negative 2 plus 4 squared minus 4, and simplify. We end up with 2 inside. So 2 times 2 squared is 4, minus 4. We end up with 8 minus 4, which is just 4. So one coordinate is going to be at negative 2, 4. Let's graph that right here. And again, looking at the axis of symmetry, which is right down the middle of the vertex, since it's symmetrical, we can also place one dot to the left of our line, 2 spaces, and connect the dots. And that's how the graph looks like for this equation. Question 12, we are asked to simplify this radical. My best advice is to think of 2 products that multiply to 50 where one of those numbers is a perfect square root. And this is what I mean. 50 is comprised of 25 and 2. The reason I chose this product and not some other number, for example 5 and 10, is because 25 is a perfect square root. And if we use the product rule for radicals, they tell us that we can actually split up these radicals and have their own. By doing so, we're able to simplify the square root of 25, which is just 5. Since 2 is a prime number, there's nothing we can do to simplify that, so we leave it as is, leaving us with 5 root 2. Same goes for question 13. So think of 2 numbers that multiply 63, but that also one number is a perfect square root. The first thing that I can think of is 9 and 7. We can split each of them to have their own radical, and now we can simplify. The square root of 9 is 3. 7 is prime. We can't simplify that any further, so we're just going to leave it as is. Question 14, we should definitely distribute that negative between the parentheses into each term. So we're going to leave the first parentheses as is and take care of that negative 1. So negative 1 times negative 5 is positive 5, and negative 1 times positive 8i is negative 8i. From here, we want to add like terms. Negative 8 plus 5 is negative 3. Positive 7i plus a negative 8i gives us negative I. We want to make sure to put the real number first and then the imaginary, because that's how we write it in standard form. For question 15, I recommend foiling out these terms to find our answer. Since this problem involves imaginary numbers, it's important to know that I squared is equivalent to negative 1. So let's get started. F stands for first. 5 times negative 2 is negative 10. O stands for outer, which means 5 times positive 8i gives us 40i. I stands for inner. Negative 7i times negative 2 is positive 14i, and L stands for last. So negative 7i times positive 8i, which gives us negative 56i squared. From here, we want to add like terms. Let's bring down the negative 10. Positive 40i plus 14i gives us 54i. And like I said, since I squared is equivalent to negative 1, negative 1 times negative 56 is positive 56. Lastly, we're going to continue to add like terms. Negative 10 plus 56 is 46. And we're going to bring down the 54i. Question 16, solve by factoring. We are working with a quadratic, so what you want to think about is what two numbers multiply to make negative 15 but add up to negative 1. Can you think about that? Negative 8 and positive 7. If we work it out, negative 8 times 7 is negative 56, and negative 8 plus 7 is negative 1, which is what we needed. Now, the square root of x squared is just x, so we're going to place x inside each parenthesis set, and we're going to put in our magic numbers in each of the parentheses, so negative 8 in one and positive 7 in the other. Since we are asked to solve, we're going to set this equal to 0. Now set each parentheses equal to 0. X minus 8 equals 0, which means that x equals positive 8. X plus 7 equals 0, which means x equals negative 7. We can place our answers in curly brackets and put negative 7 first and 8 last. Question 17, we are also expected to factor. The thing is, our a value is not 1. So what you want to do with this problem and with any other problem similar to this one, copy down the first term and the last term, the third term. Leave some space in between because we're going to find two new terms to go in the middle. To find these new terms, we are going to multiply the leading coefficient of x squared and your constant. 4 times negative 5 is negative 20. These two terms should multiply to negative 20 and also add up to negative 1. If we write out factors of negative 20, we have 1 and 20, 2 and 10, 4 and 5. Of these pairs, which one can potentially add up to negative 1? The last one. We need to assign a negative to the 5. That way, if we were to add them, negative 5 plus 4 equals negative 1, which is what we wanted. And since they need to add up to negative 1x, these two new numbers we found have an x next to them. I'm going to place the positive 4x next to the 4x squared and the negative 5x in front of the negative 5 so that we can group factor. Taking the first two terms, their greatest common factor is 4x, leaving us with x plus 1 on the inside. Same goes for the last two terms. Their greatest common factor is negative 5, leaving us with x plus 1. Since they now share a common factor of x plus 1, let's take that out, leaving us with the terms outside. 4x minus 5. Set that equal to 0. Now set each parentheses equal to 0 to solve for x. The first one is equal to negative 1. The second one, set it equal to 0. Add 5 to both sides. Equals 5. Divide everything by 4. So x equals 5/4. The answers to question 17 are negative 1 and positive 5/4. For question 18, we're going to solve using a different approach because they do want us to take the square root. So what we're going to do is we're going to isolate v squared. We're going to add 6 to both sides. So the left side cancels. If we add 6 to the right-hand side, 30 plus 6 is 36. Anytime you square root, make sure you put a plus or minus in front of that number. leaving us with v equals plus or minus the square root of 36 is 6. So we have two answers, one at positive 6 and one at negative 6. For question 19, we want to do the same thing, isolate b squared. We're going to move over that negative 4 by adding it to the other side, leaving us with 9b squared equals negative 41 plus 4. 9b squared is equal to negative 37. Divide both sides by 9, leaving us with b squared equals negative 37 over 9. Square root both sides. Don't forget the plus or minus. So we are left with b equals plus or minus the square root of negative 37 over 9. Now, since we've already been introduced to imaginary numbers, it's okay to have a negative in the radical. We're just going to simplify and rewrite like this. Negative 37 over the square root of 9. So again, the square root of a negative number is I, so we can take that out. 37 is actually a prime number. We cannot simplify, so we're going to leave the 37 inside the radical. But the square root of 9 is a whole number, it's 3. So we're going to leave that in our denominator. b equals positive I root 37 over 3 and negative I times root 37 over 3. Question 20. Solve the equation by completing the square. When you complete the square, you are adding a new term into your equation, and this is how you do it. You're going to copy the first term, r squared, and the second term as is. We are going to be adding this new term, and I will show you how in a second. We're going to copy the rest of the equation down. Since we're adding a new term, it's very important to subtract it from the same side of the equal sign. Set it equal to 0. Now, how do we find this new term? You take your b value, you divide it by 2, and you square it. So let's do that. Plugging in negative 12 for b, we get this. Negative 12 over 2 is negative 6, and negative 6 squared is positive 36. So this is the new term we are adding. Now, if we're adding 36, we're now going to subtract 36. Like I said before, from the same side of the equal sign. R squared minus 12 plus 36 factors out into r minus 6 squared. And how did I get this minus 6? You take your b value and you divide it by 2, and you get negative 6. Now we want to combine like terms. 15 minus 36 is negative 21. Set that equal to 0. Now we're going to add 21 to both sides, leaving us with r minus 6 squared equals positive 21. Square root both sides, plus or minus. We're left with r minus 6 equals plus or minus 21. The last step is to add 6 to both sides. So r equals 6 plus or minus the square root of 21. Since 21 does not have any factors that are perfect square roots, we're just going to leave it as is and say that our r value is 6 plus root 21 and 6 minus root 21. That concludes part 2. Thank you for studying with me, and please check back later for part 3 coming very soon. Happy studying!